Well, same thing we just did, but I'll do this anyway. Realize I'd use the same number up here. If this will cooperate for me, I was trying to erase. No wonder. Okay, let's try this instead. All right, sorry about that. Just do the same thing we just did. I want to get rid of grams. I want to change to centigrams. And centi stands for 10 to the minus 2. 10 to the minus 2 or 1e minus 2, same thing. Again, the 1 up here is implied. And this is actually one thing I think it's in a later slide, but I should have mentioned earlier, is significant figures. This is a defined relationship. So even though this shows 1 sig fig up here, this has an infinite number of sig figs on both the top and bottom. Because this is a precise relationship. And of course, grams cancel grams. My units left are centigrams, which is a great way to double check that I'm getting to the answer I want. And I get 9.23 times 10 squared. And that's it. If we look at how many millimeters are in 2.23 times 10 squared kilometers, let's look at this. 2.23. Now here we come into a problem. We put kilometers on the bottom here, but unless you know the metric system really well, I recommend don't do that anyway, you don't know how many kilometers are in a millimeter, or vice versa. So if you're going from one prefix to another, always go through the base unit. So in this case, we're going to go from kilometers to meters first, because we do know how to do that. 1 kilometer is 1,000 meters. So my kilometers are going to cancel out my kilometers. Then I can continue, or you can write this out in 2 steps if you want to. Now I need to get rid of my meters, and now I can go to millimeters. And the 1 millimeter is 1 e to the minus 3. Then I figure out my answer. I'll write it down here because I think I might run out of space. I would suggest you do this first yourself before you look at my answer. I'd really like you to do it in your head first and then use your calculator to make sure that you're getting the same answer and make sure that it makes sense. So go ahead and do that, and I'll give you my answer. So this equals 2.23 e to the 8th millimeters. If you're not sure about the answer, over here on the bottom we've got 10 to the minus 3. When it goes over to the top, it becomes 10 to the plus 3, so we get 10 squared times 10 cubed times 10 cubed gives us 10 to the 8th. So simple enough. Always go to the base unit. Here, some people still want to shift decimal points. They're taught to go 10 places to the left, 5 to the right. I stress this too many times, and pretty close to half the people that still try to do that on exams get it wrong because they go the wrong direction. So outside of getting it wrong, there are other reasons also that it's not going to work. I'll show you some examples of that a little later. Okay, let's do these first. Show you why you can't always shift decimal places. All right, let's go to milliliters to liters. So simple enough. Milliliters to liters. Of course, 1 milliliter is 1 times 10 to the minus 3, or minus 3 liters. And so we get 4.34 e to the minus 3 liters. And again, we're describing a small volume. A milliliter is a cubic centimeter. You think about syringes when you get an injection as a doctor is on the order of 1 to 5 milliliters. You know how big a liter is. You go buy a liter of soda or 2 liters of soda. So we're describing this small volume in terms of a large volume. So we expect to be getting a small number. So we expect this exponent here to be small. So again, it correlates to what we expect. Just one more with 2 steps. Again, try this yourself first. Then follow my answer here. Make sure we agree. All right, so 3.3 times 10 to the 3rd kilograms. Hopefully, if you work this out, you went from kilograms to the base unit first to grams, so really like we did up front, same thing. Then we go from grams to milligrams. And this equals 3.3 times 10 to the 9th in this case. So pretty straightforward. I think that's actually very similar to the previous problem with meters, or kilometers to millimeters. All right, now these are good examples of why you cannot shift decimal places. Outside of using dimensional analysis makes the rest of the math in this course really easy. So we're using the metric system because it's easy to visualize to get you a way to practice using dimensional analysis. If you shift decimal places, you're going to get it wrong when you do this. So here we have 4.25 10 to the minus 3 meters squared is what it should be. Sorry, this software doesn't like doing superscripts for some reason. I need to upgrade my software sometime. And we're trying to get to millimeters squared. So I'll do meters and millimeters. We don't know how to do meters squared, so you can't put meters squared down on the bottom. We can only do meters to millimeters. I think, what good does that do us? Well, we know 1 millimeter is 10 to the minus 3 meters. This will get rid of one of my meters in my initial value. So then I just need to do it again. Now this will get rid of my other meter, and my units left are going to be millimeters times millimeters, which is millimeters squared, which is what this answer is supposed to be up there. And then I just do the math. So this equals 4.25 times 10 to the 3rd will be your final answer, millimeters squared. And that's it. So using that same logic, try your hand at the last problem here, and then I'll work it out. All right, so we have 1.2 times 10 cubed centimeters cubed. I want to go from centimeters. I need to go to meters first because I don't know how to do anything else. Centimeters to meters is 10 to the minus 2. Again, centi stands for 10 to the minus 2. Since I start with centimeters cubed, I've got to do this 3 times. I could write it out 3 times, or if I could find my, there it is, lost track of my pointer. I can just cube this entire thing. I'm same as doing it 3 times. That will cancel out my centimeters cubed and will give me meters cubed on the top. So now I need to get rid of my meters cubed, so I'll put meters on the bottom and kilometers on the top, which is what I'm trying to get to, except I want it cubed. So 1 kilometer, of course, is 10 cubed, or 1,000 meters. And of course, this has to be cubed also. So I'll reduce this, and this is good just out of habit. Use equal sign so I can follow what you're doing when you have exams and quizzes and things. 1.2 you cube centimeters cubed. When you cube, you got to cube everything inside of parentheses. So we have 10 to the minus 6 meters cubed over centimeters cubed. We have kilometers cubed on top. We get 10 to the 9th meters cubed on the bottom. Centimeters cubed cancels centimeters cubed, meters cubed cancels meters cubed, and our final answer will be 1.2. You can work this out yourself, preferably in your head first, then use a calculator to double check. E to the 3 minus 12 it should be. If I've not done that correctly, then just yell at me. Let's see, double check that. 10 to the minus 15, 10 to the minus 12 should be right. And that's it. So again, with this shows first with the metric system why you cannot just shift decimal places when you have things to, that are to more than the first power. But aside from that, we're using the metric system because you can visualize the units better and understand why we're doing dimensional analysis, so you can see better how it makes sense. But that's a simple tool. If you have a good handle on it, it makes, again, the rest of the math in this class just much, much easier. And here, I think last two examples. When doing conversions, it's not always on the bottom where you put your conversion factor or your units that you're trying to cancel out. We're trying to change two different units. People try to separate these out sometimes and put the centimeters in one calculation, the meters in another calculation, and do these, or minutes in this case, and do some really weird things. Leave them as they are. Don't mess with your initial values. Just do one at a time. So in this case, I want to get rid of centimeters. Okay, sorry, phone call, and I got lost track of what we're talking about. All right, centimeters. I want to convert that into meters. So centi is 10 to the minus 2. So centimeters cancel centimeters. To convert minutes, now in this case, I could, again, write this out as I could do two calculations or just do one here. Minutes need to go on the top, though, however you're doing this, because it has to cancel out minutes on the bottom. And I need to put hours on the bottom here. Well, that's the units I want at the end. I want hours to be on the bottom in my final answer. And you need to know conversion factor. I expect you to know this, but this is where you need to think about it and make sure that it makes sense. People do weird things here. I've had people tell me there's 24 minutes in an hour. I've had people say there's 60 hours in a minute. Make sure that your answer makes sense. Now, I know you all know that there are 60 minutes in an hour. Just make sure that's what you put down. So when you work this out, of course, now in this case, minutes are on top. They cancel minutes on the bottom. My units are going to be, they should be, meters per hour. Only units left. And then I have to calculate this out. And I actually need a calculator for this one. I know it should be 0.088. Should be around 5 or so, I think, if I did that correctly. Well, let's see. 8.32. Oh, come on. I have it in my calculator. 8.32. Oh, it's alpha power 10. What was I doing? It should be 52.99. That's what I get here. So my calculator tells me, but we've got 3 sig figs here, but these two conversion factors are exact, so I need to round to 3 sig figs, so I actually get 53.0 meters per hour for my final answer. Okay, I'm back. I recalculated that. Some of you might notice, if you work this out yourself, something odd. I left this up here because this is a good example of, I punched in my calculator, it gave me a number that was all by power of 10 from what I thought it should be. Said it should be around 5, and ends up, I double checked, I did something wrong with my calculator, not sure what, but the final answer should be 4.992 meters per hour. Of course, I got to round off, get rid of that 1 sig fig, so 4.99 meters per hour is the final answer. Again, that's a good way to show you that you need to have a ballpark idea of what your answer should be, so when you make calculator errors, you can catch yourself. Last problem, how many liters are there in 2.33 times 10 squared centimeters cubed? What that should be. So This is why I mentioned you need to know certain conversion factors with volume, otherwise it becomes a royal pain. If you remember that there's 0.1 meters times 0.1 meters times 0.1 meters in a liter, that's the definition of liter, you can get it from there. I think it's much easier to remember. I wrote down below here one of the relationships I told you earlier. 1 centimeter cubed equals 1 milliliter equals 1 cc. That way we can actually convert from length cubed to liters to get to our answer in this case. So I need to get from centimeters cubed to, I can go to milliliters in this case because I know there's a 1-to-1 ratio. And now I can go from milliliters to the answer that being asked for in liters. Of course, this is 10 to the minus 3. And multiply this out, you get 2.33 times 10 to the minus 1 liters to your final answer. And make sure this makes sense. And I know that there are 1,000 cubic centimeters or 1,000 milliliters in a liter. This is 233 milliliters. So it should be around 0.2 liters, and that's what it is. So again, it makes sense just doing a sanity check. Something always good to check out when you're done.